Hello everyone, welcome back to lecture 6 of electrostatics. In this lecture, I will be teaching you electric field. In fact, on electric field, I will be making 3-4 lectures. In this lecture, I will teach you what is electric field due to a point charge, vector form of electric field. Then we'll do some basic questions based on principle of superposition. And at the last, we'll do some good questions which will contain some graph and vector questions. Okay, in which I will relate with vectors. Clear? The next lecture will come on continuous charge distribution, in which we will find electric field due to a finite line charge, infinite line charge, axis, or at any point. Okay, electric field due to a semicircular ring at the center, due to a disk, due to a arc, hemisphere, all those things we'll find out. And in the last lecture of electric field, I will be teaching you the entire electric field, how I can relate with mechanics, mostly with the projectile motion and circular motion. Like there what we have, I am throwing a particle of mass m at speed u at an angle theta in gravity. What we find out? H max, time of flight, range. Here what I will do, I will throw a charge in electric field. Things will be same, just acceleration will change. Okay, like there gravity was there, here acceleration will be given by electric field. Then I will ask what is the minimum velocity given to a charged particle which is suspended so that the charged particle completes circular motion. So there what we used to get root 5 gr. There gravity was there. Here I will bring charge and electric field. Okay, so no need to worry, we'll do that very properly. Okay, so in today's lecture right now I am going to teach you what? Electric field. Electric field. Symbol is capital E. Okay, before starting this, if I drop this pen, it will go down, is it? Or if I jump from here, from the 4th floor, if I jump, I will go down. So when I jump from here, did something came from earth and pull me down? Your answer is no. So when you jump, gravity was there, gravity pull you down. Now from where that force came? So I hope you all know that every mass has its own gravitational field. In the same way, earth has its gravitational field. In that gravitational field, every mass will experience a force, which is mg. So when I will jump, gravity will pull me down. The gravitational field of the earth will apply a force on me. Is it? Earth has gravitational field. In that gravitational field, if I will jump, I will experience a gravitational force which will take me down. The force is at every moment. Right now also gravity is acting on me, mg is acting on me, but normal is balancing it. When I will jump, only mg will act on me and I will go down. So every mass has what? Its gravitational field, in which other mass experience force. Earth has its gravitational field. So when I will jump, that field will pull me down. And it's a non-contact force. This force does not depend upon contact. Is it? Without contact also this force will be there. I hope you're understanding. In the same way, if you remember in the last 3-4 lectures, what I have taught you, force between two charged particles. If we have two charged particles, let's say Q1 and Q2, and let's say both are positive. So you will say, okay sir, both are positive. Q1 will repel Q2. This will be force on 2 due to 1. At the same time, 2 will repel Q1, force on 1 due to 2. You tell me, did Q1 went and push Q2? Did something came out, or just Q1 just ran and hit Q2 and Q2 experience a force? Your answer will be no. Is it? Or if I say I will hide this charge, then also force will be there. Or if I will say I will stand in between, then also force will be there. Is it? We have done question based on that. I have brought dielectric in between, one charge in one medium, other charge in other medium. Whatever I do, the force is there in between. It means, can I say, like earth was creating some field, in that field each mass experience force. In the same way, every charged particle creates something in the surrounding. It's not like this. We will do that. How does it look like? This charge creates something in the surrounding. Is it? This white, whatever I have done, this is something created by Q1. Now whatever this Q1 is creating, that is applying force on Q2. And at the same time, this Q2 also creates something in the surrounding. this Q2 is also creating something in the surrounding. Now whatever this something Q2 is creating is applying force on Q1. It means a charge particle creates something in the surrounding, creates something in the space. In that space, when other charge particle come, it experiences force. So if we have two charge Q1 and Q2, so this Q1 is creating something in the surrounding, in the space around it, and when this Q2 will come in that, it will experience force. At the same time, this Q2 is also creating something in the surrounding. Now whatever this Q2 is creating, when Q1 will come, this whatever is coming out will apply force on Q1. It means every charge particle creates something in its surrounding. In that surrounding, when a different charge particle will come, if any other charge particle will come, it will experience force. Now whatever this charge particle creates in the surrounding, we call it electric field. Is it clear? Is it clear? Now connect. Every mass creates something, that is gravitational field in its surrounding. Another charge experiences force in that. In the same way, every charge creates something in the surrounding. When I will bring a second charge, another charge in that surrounding, that charge will experience force. It's a non-contact force. It's not like Q1 is going and hitting Q2. Is it? Whatever you put in between, force will be there between them. Is it clear? Now, we cannot practically see these fill lines. These are invisible. I will draw. To make understand, we have drawn the fill lines. But fill lines does not look like, we cannot see them. They are invisible. But to make you understand, we will draw fill lines. In the same way, whatever that invisible fill lines are doing, in that to make that correct, whatever they are doing, we will make some fill lines to make you understand. In reality, the fill lines are invisible. We cannot see them. They create an effect. To understand that effect, we draw these fill lines. Clear? Fine. This is not the actual fill lines. I will show you what is the fill line look like. Understood? So every charge, you can write, let's write down the definition of electric field. Electric field, it's the surrounding, it's the space surrounding, you write, it's the space surrounding an electric charge in which if another charge particle comes, in which if another charge particle comes, it experiences attraction or repulsion. Clear? You can just make a diagram. Q1, it creates something in the surrounding, in which if Q2 will come, it will experience force. At the same time, this Q2 is also creating something in the surrounding, in which this Q1 experiences force. Just to remember, this is just to remember that Q1 creates something in the surrounding, in which if Q2 will come, it will experience force. At the same time, Q2 will create something in the surrounding, in which Q1 will come, it will experience force. Clear? Write this, pause and write. Done? Write one more statement. Every charge creates something in the surrounding. Every charge creates something in the surrounding, in which if another charge come, it experiences force. That something is known as electric field. I hope you understood. Got the feel? What is this? Okay, let me give you more feel of this. Now, we'll talk about this intensity of electric field. But before that, you should know, if I have a positive charge, from positive charge, this electric field goes away. From positive charge, this electric field goes away. We'll discuss in depth about these fill lines. Right now, just for positive and negative, you keep in mind, from positive charge, this electric field goes away. And this goes till infinity. This goes till infinity. These fill lines are stretching till what? Infinity. Same, if we have a negative charge, electric field line electric field line terminate into negative charge. Electric field line terminate into negative charge. So positive charge, electric field goes away. Negative charge, electric field terminate. Clear? Draw it. Pause and draw. Done? Okay. And keep in mind, this goes till infinity. This comes from infinity. This is going till infinity. Next. So I told you what is this electric field. Now we have to find out what will be the magnitude of this electric field. At different point, what will be the value? Like if, let's say I'm standing here. If a charge, I'm a charge particle. If a charge particle is close to me, I will apply more force. It means whatever I'm creating has more strength. If a charge particle is far away, it will experience less force. It means whatever I'm creating will apply what? Less force. It means whatever I am creating, that electric field has different strength at different point. So let's find out what is electric field intensity. Electric field strength or electric field intensity. Okay. So how this is defined? Actually, electric field intensity is defined as force experienced by a test charge divided by test charge. Don't worry, I will tell you what is this test charge and what is the meaning of this. In fact, they write here one more thing, limit test charge tending to 0. No need to worry about by seeing this limit and all. In simple words, how they have defined electric field. So let's say I have a charge Q. I have a charge Q. I want to know at r distance what is the strength of electric field. How much electric field it is creating at r distance. That's what we have to find out. So what this states that what you do, the point where you want to find out electric field, bring a test charge there. What you do? Bring a test charge. This Q naught is what? It's a test charge. You bring the test charge at the point, let's name this point as O. So we have to bring a test charge at the point O. This is Q naught. After bringing the test charge at point Q naught, you find the force on Q naught and then divide by Q naught. Whatever you will get, that will be the electric field of this charge. Clear? So what I am saying, bring a test charge here. So electric field will be, let's find the magnitude, direction and all vector form will find out, don't worry. So magnitude of electric field will be, bring a test charge, okay, I brought. What will be the force on this test charge? K, Q, Q naught by distance is R square, divide by the test charge Q naught cancel out, and the electric field strength at distance R came KQ by R square. This is the magnitude of electric field due to a charge capital Q at a distance R. Now listen. From the last 2 minutes I am saying test charge. What is this test charge? This test charge is basically a very small positive charge. Very small positive charge. In boats they ask about this. Now the question is, why very small? You tell me one thing, if I will jump from the 4th floor, I will go down because earth will attract me. But at the same time, I will also have some of the gravitational field. I'm also a mass. I will also have what? Gravitational field. So my gravitational field will pull earth up. Force between two mass is what? G m1 m2 by r square. So whatever force earth is applying on me, same force, let's say earth is applying, let's say 100 Newton on me down. Okay, same force, it's basically 1000 Newton mass into G. My mass is 100 kg into G, which is 10. Okay, so earth is pulling me down with 1000 Newton. I am also pulling earth up with 1000 Newton force. But as earth is very heavy, very heavy, its acceleration is tending to 0. Acceleration will be what? Force upon mass. Force on earth is 1000. Mass is very large. So acceleration is tending to 0. So velocity of earth is not changing. But when I am jumping, on me force is 1000. What is my acceleration? 1000 by 100. 10. Gravity. On me acceleration is what? G. My velocity will change by 10 every second because acceleration is 10 meter per second square. Is it? So for Earth, I am a test mass, very small mass. I will not affect Earth. Are you understanding? Or the field produced by Earth, I cannot affect that field. Same thing, whatever field I am creating, I am finding because of this Q charge, I want that this charge field should not get altered. If I will bring a big charge, this big charge will repel this charge, distance will change. Or in the surrounding, whatever field this is creating, that big charge will also change that field at a particular point. It's difficult to find out the field of this charge. That's why I bring a very small charge. If I bring a very small charge, it will not affect capital Q. This is the reason why we say test charge is very small and positive. Because I want that this test charge should not affect the charge because of which I am finding electric field. Is it clear to everyone? What is this test charge? Fine. So this is the magnitude of electric field due to what? Due to a charge at a distance r. Now this is electric field due to a point charge. Okay. So keep in mind this formula has came for what? Electric field due to a point charge. For continuous charge, I will teach how to find out in the next video. Okay. So due to a point charge, electric field is kq by r square, and keep in mind if it's a positive charge, electric field is away. I showed you in the last diagram, from a positive charge electric field goes away, negative charge electric field terminate, comes inside the negative charge, go away from the positive charge, and the magnitude is kq by r square. Clear? If I ask you to plot graph between magnitude of electric field and charge keeping r constant. So when we plot between E and Q, I will assume R constant. So you can see if I increase the magnitude of charge keeping distance constant, electric field will increase. They are proportional. Is it? Magnitude of electric field is proportional to charge. More charge, more electric field. So both has power 1. So graph will be what? A straight line. Clear? And what about electric field and distance? Electric field and distance. So when I am plotting between electric field and distance, it means charge is constant. Charge I am not changing. So electric field is kq by r square. So r power is -2. It's not 1. R power, it will go up, r power -2. So one thing is sure, graph is not a straight line. A straight line means what? Y is equal to mx plus c. Y and x power should be 1. Now when r is tending to 0, something by 0, electric field is tending to infinity. Is it? And when r is tending to infinity, when r is infinity, infinite square will be infinite. Something upon infinite? 0. Then electric field is tending to 0. Mark. So r0, electric field infinite. X-axis, r is on the x-axis. X-axis 0, electric field. Y-axis infinite. And when r is tending to infinity, electric field is tending to 0. And join them with a curve. This will be the graph between E and R. Now I think some of you will think, sir, why you are not plotting, if your graph is not clear, you will think, sir, why you are not plotting graph like this. If you plot like this, the problem is, this graph is saying that I will cut the axis. Electric field will go till infinity. At infinity, field will become 0. But if you make a curve like this, it will cut. And we cannot reach infinity. Graph should not cut this axis. That's why make graph like this. This will keep on going till infinity. Is it clear? I hope you understood. Pause and write. And one more thing. Okay, just write, then I will tell on the next page. So I told you that electric field is force on a test charge divided by test charge. Clear? And just now if you check, we got the formula of electric field from here, that because of a capital charge Q, not only here, anywhere, if you are finding electric field because of any charge distribution, your work will be find the force on the test charge, where the point where you are finding the electric field, and divide by the test charge. Clear? So can I say in simple word that this charge Q at distance r, Just now we got to know it's creating what electric field? First thing, it's creating electric field away because it's a positive charge. How much electric field it's creating at this point? What is the magnitude? You will say, sir, kq by r square. This is the electric field this charge is creating here. Now at this point in space, it means if one charge is there, it will create electric field in all direction. Now force is not there. When a second charge will come, another charge will come, it will experience force. So if I bring a charge q naught here, now this q naught will experience force. And from here you can see force is QE. Force is QE. I'm going in opposite way now. I know field, I'm finding force. So force will be what? So force on test charge will be test charge multiplied by the electric field present at that point. So test charge is Q naught. And who is creating electric field here? The capital charge Q. How much electric field? KQ by R square. So force will be what? KQ Q naught by R square. This is what was Coulomb's law. Is it clear to everyone? Understood? Pause and write. I will show you one more example like this. Let's say I have a charge Q1. At R distance, how much electric field it will create here? Means how much power it will generate here? Power means how much power he is having. If someone will come, I will apply force. So let's see. So at this point, this charge Q1 will have what electric field? K Q1 by R square. If I bring a charge Q2, this Q2 will experience force. What is force? Force on a charge is the charge which you are bringing multiply by the electric field of the other charge. Electric field of other charge Q1. So force on Q2 will be the charge Q2 into electric field of Q1, which is K Q1 by R square, which is ultimately K Q1 Q2 by R square. This is the actual way to get the field between the forces. So I have taught you force between two charges K Q1 Q2 by R square. But practically what is happening? One charge is creating a field at that location. When other charge is coming, it's experiencing force. Same, this charge is creating a field at this location. When a charge is coming at this location, this charge is experiencing force. I hope you understood. Is it clear? Same you will say that this charge, which charge? Q2. This Q2 is creating what electric field here? From here distance is R. So Q2 will create what electric field? K Q2 by R square. And who is present here? Q1. So Q1 will experience force. How much? So force on Q1 will be Q1 into electric field of Q2, which is K Q2 by R square. So force will become K Q1 Q2 by R square. This is what happens practically. One charge creates electric field, other charge experience force. Now don't think in this way, sir, Q1 creates electric field, Q2 also creates electric field. So on Q1 will also apply force, Q2 will apply force. No, Q1 will not apply force on itself. Q1 field will not apply force on Q1. If you are going to gym, if you are doing bodybuilding and all, if you have power, you will not use your power on yourself. You will not beat yourself. Whatever field Q1 is creating, that field will influence the other particle coming in the surrounding. Whatever field Q2 is creating, it will influence the other particle in the surrounding. Is it clear? So let's say a question came like this. So you understood na, that electric field is force by charge. Is it? If I say in a region, this is a region where we have electric field, let's say 10 Newton per Coulomb. From where this field is coming, how this field is coming, no need to worry. Because some external source, the field is coming. If here I keep a charge 2 Coulomb and I ask you, what is the force on 2 Coulomb? Now don't say, sir, K Q1 Q2 by R square. We don't have two charges. We have only one charge which is present in an electric field. So then you have to use this formula. Keep in mind, okay, if a charge will come in an electric field, from wherever that field has come, doesn't matter, that charge will experience force. So force on this charge will be the charge multiplied by the electric field in which the charge is present. That electric field is everywhere 10. It's a uniform field. 2 into 10, answer is 20 Newton. Same thing is happening everywhere. Q1 is creating electric field in which Q2 is experiencing force. Q2 is creating electric field in which Q1 is experiencing force, which is coming K Q1 Q2 by R square. But here charge was not given. I gave you electric field. In this region, electric field is 10. A charge came 2 coulomb. So 2 coulomb will experience force. How much force? Charge into field. Like let's say my mass is 100 kg. I am in a gravitational field. Gravitational field value is 10 meter per second square. So how much force is acting on me? My mass into G. This is a force because of gravity. In the same way, electric force is charge multiplied by the electric field in which the charge is present. On this we'll solve a lot of questions in the coming lectures. After 2 lectures when I will connect with mechanics. Till here clear? Pause and write. So till now what you learned? We learned that because of a positive charge at r distance, electric field is kq by r square. Negative charge also, value will be kq by r square, direction will be different. From positive charge, electric field is away, negative charge, electric field is towards. Clear? I hope you understood. Any doubt? What will be the unit? So this electric field is force by charge, or force on a test charge divided by test charge. So this electric field unit will be what? Newton per coulomb. What will be dimension of this? Dimension of electric field. So dimension will be Newton, mass into acceleration. What is acceleration? Meter per second square, mass kg. So what is dimension of force? Dimension of force is mlt power minus 2. Dimension of force is mlt power minus 2. Mass into acceleration, meter per second square, divide by charge. Now charge is not a fundamental quantity, charge is derived quantity. So can you tell me this in terms of fundamental? So we know current is charge upon time. So charge is current into time. Current is a fundamental, time is a fundamental. So ampere into T. So divide by ampere, is it, into T. So what you will get? Dimension of electric field will be ml a power minus 1 t power minus 3. This is dimension of electric field. It's a vector quantity away from the positive charge and towards negative charge. Is it clear? Pause and write. Next, vector form of electric field. Vector form of electric field. Again, let's say we have a charge, same like I have done the Coulomb's law vector form, same. Let's say we have a charge q. At this point O, I want to find out electric field at O. So what you will do? The point where the charge is present, from there you join O. This is our position vector R. What is R? Position vector. From where to where? From the position of charge to the point where I am finding the electric field. Okay. So what you will write? If you remember, vector quantity has two parts. One magnitude, one direction. So you will write electric field will have one magnitude. What is magnitude? Just now we have calculated kq by r square. Is it? This mod r, right? Mod r square. Clear? Mod r means this magnitude. Now, let's say it's a positive charge. So from positive charge, electric field is away. Electric field is away. This is electric field. I want to write direction of electric field. Can you see any vector in direction of electric field? We know for every vector quantity we have one direction and we have one magnitude. I wrote the magnitude. Now I want to write the direction of electric field. For direction we take the help of unit vector. First you tell me, can you see any vector in direction of electric field? Yes, position vector R. This R is in direction of electric field. It means I can take the help of position vector to find out direction of electric field, and position vector and direction we find with the help of unit vector. So electric field has same direction as position vector, and to find out direction we take unit vector. So I will take unit vector of position vector. Is it? Because R and E are in same direction. Now from here what you can write? As we know, if we have a unit vector, it is equal to vector upon its mod. So I can write this as E is equal to kq by, what is unit vector? Vector upon its mod, and here we have r square. So I will combine this and I will write electric field E is equal to kq by mod r cube into r. If question comes in vector form, put charge with sign. In vector form, we have to put everything with sign in vector form. So if question comes in vector form, you use this and put everything with sign. But if the question does not contain direction and all, no one will put negative charge or positive charge, sign of negative. We will only take the magnitude. Okay, means don't take minus. Like in Coulomb's law, I told you, no, never take minus sign. Always do k mod q1 mod q2 by r square, and minus and all will tell direction, attraction, repulsion, that we will find out with common sense. Same here also. You just take what? Magnitude. When we are not doing in the vector form, just take the magnitude, and with plus and minus we will find the direction. If it's a positive charge, electric field is away. If it's a negative charge, electric field is towards. This is the vector form of electric field. Clear? KQR upon mod R cube. Understood? Take charge with sign. And if it's a negative charge, electric field will be left. So electric field and position vector will be in opposite direction, which means minus sign. Just put a minus sign. I hope you understood. Clear? Just pause and write. Okay. I will give you one question based on this. Let's do one question on this. We have, at last also I will take one good question. We have a 2 coulomb charge whose coordinate is 2, 1. And here we have a point O. I want you all to find electric field at point O. Point A has coordinate 3, 4. So what you will do? I want you to find out electric field in the vector form. Okay, so you will say, okay, electric field in vector form will be, at O will be K. It's in air, so K, Q into vector R, KQ, vector R upon mod R cube. Is it? What is vector R? Position vector. Is it? So you will join this charge with O. This is your position vector. Clear? So what is coordinate of this point? 3, 4. So what I can write this as? 3i cap plus 4j cap. What is coordinate of this point? 2, 1. So what I will write this as? 2i cap plus j cap. Is it? What is position vector? If I say, let's say this is R2. This is the position of the point where I am finding field with respect to origin. Okay, coordinate will tell about what? Origin. About 0, 0. So about 0, 0, about origin, I know the position of this. About origin, I know the position of this. 2i cap plus j, 3i cap plus 4j. So what will be this R position vector? Final position about origin minus initial position about origin. So this will be final minus initial. 3i cap minus 2i cap, I cap, 4j cap minus j cap plus 3j cap. This is our position vector from here to here. What will be its magnitude? Under root a square plus b square, or x square plus y square. What is here? Coefficient is 1. So 1 square plus 3 square. So what you will get? Root 10 meter. So what you will write here? K, 9 into 10 power 9 into charge. What is charge? Charge is 2 coulomb. Then what is vector R? So vector R is this vector, means position of this with respect to origin minus position of this with respect to origin. This position is 3i cap plus 4j cap. This position is 2i cap plus j cap. I subtracted both of them. I got this position vector. So this will be I cap plus 3j cap divided by mod R cube. What is mod R? Root 10. So root 10 whole cube. This Newton per coulomb will be the value of electric field at O in vector form. This is what they can ask. Clear? Now I can bring multiple charges also. We'll talk at the end. Okay, this is sufficient. Just pause and write. Clear? So position of this was given, position of this was given. I have calculated this position vector. We know in vector form, the formula of electric field is kq vector r upon mod r cube. I just substituted, I got the answer. Clear? Fine. Let's move to next part. I can give you a bit of more feel by saying a simple word, that electric field is the force on 1 coulomb charge. Just think whatever I have told. Just think. If you check, because of q charge at r distance, electric field is what? K q by r square. Is it? And if I ask you again, q charge at r distance, I kept a 1 coulomb charge. What is force on 1 coulomb charge? Force on 1 coulomb charge because of this charge will be K q1 q2. This is 1 by r square. See, same thing came or not? So all of you write, electric field is force on 1 coulomb charge. Electric field at a point is force on 1 coulomb charge. Electric field at a point is force on 1 coulomb charge at that point. Electric field at a point is force on 1 coulomb charge at that point. So whenever you are confused with electric field, no need to worry, just keep there 1 coulomb charge, and whatever you get, that will be also what? Electric field. Clear? You can write this. Next we will do principle of superposition. Principle of superposition. This also we have done before, if you all remember. Is it? Let's say we are having Q1, Q2 and Q3. Three charges we are having. At this point, I want to know what will be the electric field. Let's say this is negative. So what you will say? Sir, find electric field because of Q1. So what Q1 will do? Q1 is a positive charge. Let's say this distance is R1, this distance is R2, and this distance is R3. You will say, sir, Q1 is a positive charge. It will give electric field away. At this point, away. Electric field due to Q1. Then you will say, sir, Q2 is also positive. It will also give electric field away. Electric field due to Q2. And Q3 is negative. It will give electric field towards. Electric field due to Q3. So at the point O, I got 3 electric field because of 3 different charge. So what I will do? Now I will do vector sum of all the field. So net field at O will be what? Net field, let's say this point is O, at O will be vector sum of electric field due to Q1 plus electric field due to Q2 plus electric field due to Q3. If you all remember Coulomb's law, I have taught this. This is principle of superposition. The electric field at any point will be vector sum of all the field due to all the charges taken one by one. One by one you will find field because of all the charge, because of Q1, because of Q2, because of Q3, and then you will do the vector sum. Now just relate with the previous statement. Electric field same as force on 1 coulomb charge. If you keep here 1 coulomb charge, then what you will do? You will find force because of this charge, force because of this charge, force because of this charge. Then you will do the vector sum of all the forces. That will be the net force. Same thing you will get because charge is 1 coulomb. I hope you understood. Is it clear to everyone? Can we move on? Fine. Let's do some problem. Fine. So this was principle of superposition. Like question number 1. This is an equilateral triangle. Here we have a charge Q of side A. You know, whatever question we have done, same question I can bring here. In force, whatever question we have done, all the questions I can bring here. And here is the point O. What will be electric field at O? It's an equilateral triangle. All of you pause and try. One more thing, you all can write on the top of your notebook. Electric field is at a point. Force is between two charges. Write this. Electric field is defined at a point. I will ask you what is electric field at this point, that point. But force is between the charges. Clear? So at this point, again in the same way like we did for force, positive charge will give electric field away. away. How much? kq by distance between the point and charge is a by a square. This positive charge will give electric field away. kq by a square. Don't write in the vector form. Do it like this. Easy. This is 60 degree equilateral triangle. So vertically opposite. This is also what? 60 degree. So we got two values. One in this direction, one in this direction. This is kq by a square. This is kq by a square. Angle is 60 degree. To reduce our time, you assume this to be E. If this is E, this is also E. Both are same. So two vectors at 60 degree. So net electric field will be under root A square plus B square plus 2 A B, which is E square. Cos 60 is 1 by 2. 2 cancel. E square root 3 square, which is root 3E. Now put the value of E. So you will get root 3 E is kq by a square. Is it? And when two vectors are in same direction, resultant, and if they are equal, sorry, not same direction, if we have two vectors equal in magnitude, so resultant will be exactly in between. If someone pull me with 10 Newton, I will come exactly in between. So net field will come exactly in between, and then net value, the magnitude of the net field will be root 3 kq by a square, and this will come exactly in between. How much? Root 3 kq by a square. If someone asks to write in the vector form, you write kq by a square, root 3, direction is up means j cap. Clear? Understood? Now if you remember, same question I gave when I was teaching you Coulomb's law. You know, but there what I told ki in Coulomb's law ki we have three charge q naught, find net force on q naught. This is what I have asked. Now I think you understood one thing. The charge on which you are finding force, who is applying force on that charge? You will say, sir, q and q. How they are applying? This is giving electric field, this is giving electric field. That electric field is applying force on q naught. Now your point of view will change. It's not like a charge is applying a force directly. This charge is creating something which is going applying force. What is that which is created? Electric field. So at this point, these two are creating electric field. How much electric field? Root 3 kq by a square. It means these two charge are creating electric field at this point. How much electric field? Just now we got root 3 kq by a square. And I told you, if a mass is present in gravitational field, force is mg. In the same way, if a charge is present in electric field, force is qe. Just now we have done, is it? So force on this charge will be what? Force will be the charge which is experiencing force multiplied by the electric field of the other charges. What is that? Root 3 kq by a square. This is nothing but root 3 kq q naught by a square. If you go and check, same thing you got. I hope it is clear to everyone. Understood? So either you find the force on the q naught, force because of this, find the resultant, or you find out electric field because of these two at this point. You got the electric field. Now this charge is kept here. Electric field will apply force. How much force? Q into E. Q is that charge which is going to experience force. Electric field is what? Due to the other charges. So this will experience force because of the electric field of these two charges. Same answer will come. Is it clear? So whatever question I have done in the Coulomb's law, all questions I can ask here. I can ask you electric field. We'll do some will do. Okay, just pause and write. Next question is, here we have a charge Q. This also we have done, if you remember. This is minus Q. What will be, or let's say this is minus Q and make this one as Q. One second. Yeah, Q. And this is a square of side A. A square of side A. Find electric field at O. Electric field at O. What will be electric field? Again, you just come and sit here. Positive charge will give electric field away. How much? kq by square of side A square. Again positive charge, electric field away. How much? KQ by A square. Negative charge gives electric field towards. So this negative charge will give electric field towards. How much? K. I have told don't take minus sign. Minus means direction I have shown. That's what I am saying again and again. Minus means direction. I have shown towards. KQ by this distance square. What is this distance? So this is A, it's a right angle triangle. This is hypotenuse. So what will be that? A. So under root of A square plus A square, which is root 2A. So KQ by R square, root 2A square, which is 2A square. Is it? Again, we have three vectors down. Let's say this is equal to E. So this will also be E. They are equal. And this is what? KQ by 2A square. And this part is E. So total will be E by 2. So we have one electric field right, one down, and one in this direction. Is it? Which is E by 2. So we have three vectors. First I will solve any two. Let's solve these two. These two are perpendicular. When two equal magnitude vectors are perpendicular, their result comes root 2 time. Or you can solve. So these two will give you what? E will give you under root A square plus B square plus 2AB cos 90, which is 0. This is root 2E. So resultant of E and E will be root 2E. As they are equal, result will come exactly in between, which is opposite to, this is exactly in between, which is opposite to E by 2. When two vectors are opposite, we can directly subtract them. So net electric field will be what? Net will be root 2E minus E by 2. I can take E common. Answer will be root 2 minus 1 by 2. Now you all can put the value of E. What is the value of E? What we have assumed? KQ by A square. So KQ by A square root 2 minus 1 by 2. What will be direction of the net field? So root 2 is more. So direction will be like this at 45 degree. Is it? These are at what? 45 degree, na? Exactly in between. So this is more than this. So answer will be root 2E, 45 degree from vertical or horizontal. And E is KQ by A square. Same thing we have done. I have kept a charge here and I ask you force. Same thing came. Now if I keep a charge here, I know what is the electric field here. So force will be the charge I am keeping multiply by electric field of the other charges which I have got. So electric field you got, multiply by the charge you are putting, you will get the force. If you check, same thing you got there also. Understood? Now if I talk about those symmetry problems, like if I ask you that we have four charges at the corner of a square of side A, what will be electric field at the center? You will say, sir, positive charge will give electric field away. This positive charge will give electric field away. This positive will give electric field away. And this positive will give electric field away. All the charge are equal in magnitude and distance also same. So all are giving same magnitude of electric field. And these two opposite cancel out. These two opposite cancel out. You will say the electric field at the center is 0. And if you remember, I have given you same question and I asked you force at the center. There also you got the force 0. I think now you can relate. So electric field is 0 because of the four charges. That's why force is also 0 at the center. Now whatever symmetrical questions we have done at the center of a uniformly charged ring, at the centroid of a triangle, at the center of a regular hexagon, in all the case the force on the charged particle was coming 0. In the same way you can say electric field is also 0. So at the symmetrical point electric field is 0. This thing you can write. Clear? Achha, one more thing you tell me. I have seen many PYQs like this. 2Q, Q, minus 2Q, and this is minus Q. At this is the center O. What is direction of net electric field? If they ask magnitude, you can find out. If they ask direction, then also you can find out. Is it? How will you find out? This positive will give electric field away. This positive will give electric field away. Electric field because of 2q, electric field because of q. Which will be more? 2q will be more because distance is same. This is charge more in magnitude, so this is more. Then electric field because of negative charge towards that negative charge towards electric field because of minus 2q, electric field because of minus q. Don't write minus sign while finding the electric field kq by r square. That q will should be always what? Positive. Minus direction that I am showing. Now, if you look here, this field, which is more? This is more. So net field will be in this direction. This field, which is more? This field will be more because this is because of minus 2q. So net field will be in this direction. Now this field and this field, now you got two field, you can find the resultant. In this case, the resultant will come exactly in between. Because whatever this 2q will give, that will be cancelled by q. Okay, and we will get some electric field. Same whatever minus 2q will give, some is cancelled by minus q. So again I will get some field here. So whatever field I will get, let's say E and D, resultant will be under root a square plus b square plus 2ab cos 90 degree, it's a square. So net field will be right. And magnitude you can find out with the help of vector sum. Many questions we have done like that, is it? In the same way, I can give you many questions based on that series. I will prefer you all to just go and see all the lectures of Coulomb's law, because from there I have taken all the variations. I'm just telling you, like this is point O, I can keep 1 coulomb here, 2 coulomb here, 3 coulomb here, 4 coulomb here at a distance of 1 meter, then this is 2 meter, then this is 3 meter, and so on. And I can ask you electric field at O. 1 coulomb will give electric field, 2 coulomb will give electric field, 3 coulomb will give away, 4 will give away, all the field will be in same direction, we will add. I can change this charge, I can change this distance, and I can make different type of series. I can make GP series, sum of GP will come. I can make ln1 plus x expansion, is it? So whatever I want I can do with these numbers. Okay, so all those things we have done, that's why I'm not taking here. Clear? Okay. Now, but one thing I will take again, that is null point. We have found out, if you remember, the point where the net force on the charged particle is 0. That part we have done there. Here also I will ask, let's say we are having a charge q and a charge 4q. Okay, and the distance between them is what? L. I want you to find out the point where electric field is 0. Find the point where electric field is 0. So you will say again, sir, we'll make 3 partitions. One this, one on the left of this, one on the right of this. Apart from this axis, nowhere electric field will be 0. Because if you take any point in space, positive will give electric field away, this positive will give away, angle will be something, net field will come. For field to be 0, the field has to be equal and opposite. It's a vector quantity. For the net field to be 0, the field has to be equal and opposite. At any point on the space apart from this axis, field will never be opposite. Take any point, take here, positive will give away, this positive will give away. They can never be opposite. So we have to check on the axis. First I will check at this point. Positive give electric field away. That positive also give electric field away. Both are away. Electric field cannot become 0. Come to this point. Again positive will give electric field away. That positive will give electric field away. Field cannot be 0. If you come in between, let's say here, this positive charge will give electric field away. That positive charge will give electric field away. Yes, this is filled because of plus q. This is filled because of 4q. Here I got both the field opposite in direction. If they become equal in magnitude, then net field will become 0. So I will assume that this point where field is 0 is at x distance from here. So from here distance will be, total is L, this is x, this remaining will be L minus x. So what I'm saying, if electric field because of Q becomes equal to electric field because of 4Q, as they are opposite in direction, if the magnitude becomes equal, net field will be 0. What is the electric field here because of plus Q? So plus Q will give how many field? How much field? K. Charge is Q, and from plus Q distance is x by x square is equal to how much field 4Q will give? K. 4Q, from 4Q distance is L minus x whole square. Clear? Now what you will do? KQ cancel. 1 upon x square is equal to 4 upon L minus x whole square. Take root both the sides. So 1 by x is equal to 2 upon L minus x. So L minus x is equal to 2x, L is equal to 3x, x is equal to L by 3. It means at a distance of L by 3 from Q, field will be 0. Or they may ask from 4Q, be careful. So from 4Q distance will be L minus x, x is 2L, L by 3. So L minus L by 3, 2L by 3. From here distance will be 2L by 3. Same question I have done when I was teaching you force. At which point force is 0, same data I have taken, same result we got. So it's very obvious now, the point where field is 0, the point where there is no field, at that point if I keep the charge, force will be 0. And if you all remember, I gave one trick also there. Trick was when both the charge are positive or both are negative, then the equilibrium point comes at root q small upon root q large plus root q small into distance between them. And this x is the equilibrium point from smaller charge, and this you will get when both the charge are positive or both the charge are negative, and this equilibrium point comes in between them. When both are positive or both are negative, the equilibrium point will be in between. Outside you cannot achieve equilibrium, you can see, because both the field are in same direction. So same direction field always add up, they can never become 0. And this was the trick which I gave, is it? So x is equal to L by 3. So the point where field is 0, at that point force is 0. Clear? Pause and write. Same thing I taught you for if one charge is positive and one charge is negative. Distance between them is L. Now what you will do? You check here, take any point. Positive will give electric field away. Negative will give electric field towards. Both the field are in same direction, net field can never become 0. Come to this point, negative will give electric field towards, electric field because of minus 4q, and this positive will give electric field away, electric field because of plus q. Yes, they are opposite. Come here, positive charge, electric field will be away. Negative charge, electric field will be towards. Again they are opposite. So for net field to be 0, the field has to be opposite and equal. They are opposite, but you know, here field can never become 0. I have taught there also. Why field cannot become 0? Because field is basically kq by r square. In this region, first you tell me which charge is greater. 4q is more in magnitude. Whatever field 4q will create, let's say for 1 meter distance, if I take 4q and q, 4q will give more magnetic field. Sorry, electric field. So magnitude wise, who is dominating? 4q charge. So 4q is winning because of charge. And you take any point here, it will be close to minus 4q. Less distance means electric field more. So any point you take here, this charge field will always dominate, because any point will be close to this. So because of closeness, field will be high, and this charge is already more. So because of charge also it will give more field. So the field because of minus 4q will always dominate. For the net field to be 0, they have to be equal and opposite. They can never become equal. Always this will dominate. So net field will be always there towards minus 4q. Field can never become 0. You will say, sir, at infinity field will be 0. But infinity you can achieve only mathematically, not physically. So if they ask mathematically, you will say yes, at infinity field will be 0, but physically we cannot achieve infinity. Here what will happen? Yes, here we can get field 0 because this is dominating charge wise. This is winning charge wise, but distance wise, this charge has less distance with this point. So less distance means more field. So this will win distance wise, this will win magnitude wise, and field will become 0. That's why field always comes 0 near to a smaller charge, because the larger charge dominates charge wise. So the point has to be closer to a smaller charge so that it can dominate because of less distance. So field are opposite, just make the magnitude of the field equal. Field because of positive charge q is equal to field because of minus 4q. Let's say this distance is x. So how much field positive charge will give? Kq by x square is equal to how much field negative will give? K4q. I told don't take minus, direction you have shown, by L plus x. L plus x whole square. So what you will get? Kq. Take root. So 1 by x is equal to 2 upon L plus x. Therefore, L plus x is equal to 2x. X is equal to L. So from the smaller charge, distance is L, and from the larger charge, distance will be L plus L, 2L. Be very careful from where they are asking. Is it clear? Here also we have a trick. Actually, it's not a trick. By keeping the variables, we have got this formula. But you can remember. So when one charge is positive, one charge is negative, equilibrium will be outside, closer to a smaller charge. There also it was closer to a smaller charge, but inside, when both the charge were positive or both were negative. But when one is positive, one is negative, equilibrium will be outside, closer to a smaller charge, and that equilibrium distance will be x is equal to root of q small upon root of q large minus root of q small into distance between the charge, which is L. Just use that trick, root smaller charge, and take mod. Don't say it's imaginary. Take mod, smaller charge will be root q, larger charge will be root 4q, smaller will be root q into L. Q cancel out, root 1 1, root 4 2, root 1 1. So 1 upon 2 minus 1. Is it? So what you will get? L. That's what we got here. Clear? So keep in mind, field always becomes 0 near to a smaller charge. Just pause and write. Now you will think, sir, already you have taught this in case of force. Then why again you taught? First thing I wanted to show you that the point where field is 0, at that point force is 0. Because this field only applies force on the charge. Second thing, the next part, the graphical part. For that, I taught you this. That graph part, first two questions will be mains and NEET level, last question will be advanced level. Okay, let me show you. So first you understand what we are going to plot. These graphs are really important. So let's say this is a charge Q and this is also a charge Q, and both are kept at some distance L. Okay, the separation between them is what? L. On the y-axis, see what is, first you have to understand what we are going to plot. A person will start to run from here, he will start to run and he will run till here. The person will start here and come here. While moving on the x-axis, this is distance axis. While moving on the x-axis, what electric field he will encounter, that I will plot on the y-axis. The net electric field, the field because of both the charge. What is net field? Field due to both charges. Okay, so person will go from here to here. While going from here to here, like at this point, he will get some electric field. This point, some electric field. This point. He will go from here to there. What electric field he is getting while going from here to here, that we have to plot on the y-axis. If electric field will be right, if electric field is right, you will consider it positive. And if electric field is left, left, we will consider it negative. Clear? If the net field is in right direction, it will be positive. So it will be plot up plus y. And if electric field is left, it will be plotted down in negative y. Clear? Understood? Now while making the resultant electric field on this axis, means the person is moving on this axis, whatever, see, let's say he is going from here to here. So while moving, what is the electric field he is getting? How much electric field is coming to this person when he is going from here to here? That we have to plot on the y-axis, because x-axis is distance. X-axis I have taken as distance. Is it clear? So while plotting this type of net electric field versus distance graph, you have to keep one thing in mind. Listen very carefully. Just pick some points. Now you will say, sir, which point? Those points which are very close to charge, and that point which is very far from the charge. What I'm saying, you pick some points every time. Pick some point. 1, 2, very close, tending to 0, 3, 4, and ekdam last mein infinity, at infinity. Okay, see, you know what will happen with this, and you check one more thing where the field is 0. So first I will look at this point. This will help you. We'll do 2-3 questions, don't worry. This point is very close to Q. So can I say distance is tending to 0? What is the formula of electric field due to a charge? KQ by R square. But you will say, sir, here we have 2 charges. Fine, we have 2 charges. But from this charge, this point is at some finite distance. Is it? But from this charge, the distance is tending to 0, very, very small. From here we have some distance L. So this charge will give some electric field here, KQ by L square. But from this charge, distance is tending to 0. If distance is tending to 0, electric field is tending to infinity. So this is dominating. This will give some field, but this is dominating. It's giving infinity. So whatever this gives doesn't matter. So resultant, who will decide here? This will decide. Now electric field is infinity. This is also infinity. This is also infinity. Which infinity? Plus or minus? You have to check. You tell me, at this point, positive charge will give electric field in what direction? Away. Positive charge give electric field away. Away means right. And right is positive. So this is plus infinity. So graph starts from where? Graph starts from here. And you know, okay, we will come there after some time. Come to this Q charge. Now when you are close to this charge, from this charge distance is 0. So electric field will tend to infinity. I will not care about that charge because this will give some finite value. This is giving infinite value. Because R is 0, electric field is infinite. Now this is a positive charge. A positive charge gives electric field away. Away. At this point, field will be away. Yes or no? If this is a charge, this is how field comes out from a positive charge. So at this point, right? At this point, left. So you can see, at this point, field is left. Left is what? Minus. It means electric field will be minus infinity. Where is that minus infinity? It's here. And you know, if two positive charges there, Q and Q, at the center electric field will be 0. Is it? This positive will give away, this positive will give away, and they are equal. So field will be 0 at the center. And field is plot on the y-axis. So y is 0 on the x-axis. Yes or no? Field will be 0 at the center. Here field is 0. So graph starts from here, 0, end here. Just connect them with free hand. Now come here, this point. R is 0. Electric field will tend to, if distance is 0, electric field will be infinity. But what infinity? Check direction. Positive charge field is away. Left. Left means minus infinity. Yes or no? So it means the graph will start from here. And when distance is infinity, this will also give 0 electric field. That will also give 0 electric field. Electric field will be 0. Distance is infinity. Electric field is tending to 0. So from here to here. Don't draw like this. This graph means you are cutting. Infinity cannot be cut. You cannot reach to infinity. So graph has to lie down like this. Clear? Come to this point. R is tending to 0. R is tending to 0. Electric field is tending to infinity. What infinity? Check direction. Positive charge field is away. At this point, away will be right. Right means plus. So plus infinity. So plus infinity is here. And when distance is infinity, electric field, because of both the charge, will be tending to 0. When distance is tending to infinity, electric field tending to 0. So graph will be like this. This is the resultant graph. Resultant electric field, what the person is encountering when he is going from here to here. Clear what electric field that person is getting, that we have plot on the y-axis. Pause and try. Pause and write. Next. Don't worry. We'll do some more. You will understand. No need to worry. Now I will take one Q and one, let's say 4Q. 1Q, 1 4Q. I want you all to try same thing. Same thing. Net electric field on Y, distance on X. The person is running from this end to that end. For your understanding, I have met this person. Again, same thing we will do. Okay, sir. Acha, one more thing. When charge was Q and 4Q, where field came 0? Just check. We have done this question. When charge was Q and 4Q, field came 0 close to smaller charge at a distance of L by 3. Remember, if total is L, this came L by 3. Okay, fine. No issue. Fine. So when here R is tending to 0, electric field is tending to infinity. Always pick this point which is very, very close. Now positive charge give electric field away. Away means right. Right means plus infinity. So graph will start from here. Then here R is tending to 0. Electric field will be tending to infinity. From positive charge at this point, field will be away. Away means left. Left means minus infinity. It starts from here. And here electric field becomes 0. It will cut the x-axis. It means the graph will start from here, here, and like this. And 4Q is dominating. It will take most of the region. It will dominate in most of the region. So don't draw symmetric. In the previous case, I have drawn a symmetric curve. Symmetric means this part and this part were equal. But in this case, these two parts are not equal. And the meaning of symmetric, the sense of symmetric is whatever we have here, domination of Q, same domination this Q has here. Okay, direction is opposite now. Then come here. R is tending to 0. Electric field is tending to infinity. Positive charge electric field will be away. At this point, away will be left. Left means minus infinity. Graph starts from here. And when distance is infinity, electric field tend to 0. Like this. Come there. Distance just close to 4Q, distance is tending to 0. Electric field will be tending to infinity. Positive charge electric field is away. At this point, away will be right. 4Q will give away. So at this point, right. Right is positive. So plus infinity. Graph starts from here. And when distance is infinity, electric field becomes 0. You will get the graph like this. Is it clear? I hope you understood. Pause and try. The question in which you feel doubt, please write in the comment section. Okay. I will make some more questions on that if you want. Next. What about Q and minus Q? Just do it fast. Q and minus Q. All of you try. Just do it fast. Q and minus Q. What you will get? Q and minus Q. You will say, sir, here R is tending to 0. Electric field is tending to infinity. Negative charge means field is towards. Negative charge means field is towards. This is left. So starting from minus infinity. And when distance is infinity, electric field is tending to 0. 0. So what you will get? The graph will be like this. Clear? Next. First I am drawing this side. Here also R is tending to 0. Is it? If R is 0, electric field is tending to infinity. Positive charge, electric field will be away. Positive charge field is away. So at this point, away will be left. Left means minus infinity. Minus infinity. And when R is infinity, when distance is infinity, electric field is tending to 0. So from here to here. What I'm doing, I'm just taking R0. Just on the right of a charge, just on the left of a charge. Just on the right of a charge, just on the left of the charge. So if distance is 0, electric field is infinity. Then I'm checking its right or left. Positive charge away, negative charge towards. So at that point, I'm checking right or left. Right means plus, left means minus. Clear? What about in between? Here, when R is tending to 0, electric field is infinity. Just write like this. Then positive charge gives electric field away. Away means right. Right means plus infinity. So graph starts from here. Just here, R tending to 0, electric field tending to infinity. Which infinity? At this point, negative means field will be towards. Towards means right. Right means plus infinity here. And you know, if one charge is positive, one is negative, if you take any point in between, positive will give electric field away. Negative will give electric field towards. The field will be always in same direction. They can never become zero. If field can never become zero, it will never cut this axis. It means it will come down and go up. Minimum value you will get somewhere. At the midpoint, you will get the minimum force or minimum electric field, but that field will not be zero. That field will not be zero. Field can never become zero. In this case, physically field will never become zero, because in between the field is in same direction. In between the field is in same direction. And if you go out, if you go here, so charges are same in magnitude. Electric field is kq by r square. The charges are same in magnitude. If you take any point here, it will be closer from q and far away from minus q. So this will give more field. Charge wise both are same. Here only distance is the factor. For field to be 0, one should dominate charge wise, one should dominate with less distance. Less distance means more field. But here, this is close to q, so this will apply more force in this region. And in this region, it's close to minus q, this will apply more force. Field will never become 0. Mathematically, at infinity, field will become 0. At infinity. That infinity and this infinity. But physically, we cannot achieve that. I hope it is clear to everyone. Next and most important graph. Next and most important graph. We have a charge q and we have a charge 4q. Let me take q and minus 4q. What will be the graph of this? I think the lecture is going a bit big. So this is the last question for this lecture. I told question based on vector form. I will take in the next lecture, no need to worry. Okay, I want you all to plot net field versus distance. One charge is q, one charge is minus 4q. What you will get? And when whenever you are plotting graph, you always find the equilibrium point. So q and minus 4q. I gave you a trick now. When the charges are opposite, so root q small upon root q large minus root q small into distance between them. This is giving me what? 1 upon 2 L. X is equal to L. But where? Closer to a smaller charge outside. Just now we have done equilibrium or the null point will happen closer to a smaller charge, and when one is positive, one is negative outside. It means somewhere here equilibrium will come. It means here electric field will become 0. Here whatever electric field positive is giving, see, positive is giving away, negative is giving towards. So at this point field becomes 0. In between field will never become 0. Positive away, negative towards, same direction. Here also field can never become 0. Why? You all remember, because negative will always dominate. Negative is more in charge. Negative will be always less in distance. You take any point, it will be close to negative minus 4q. So this will dominate charge wise also, and because of less distance also. So here field will be opposite, but they will never be equal. So what you will do here? Again, same thing. I want you all to do by yourself. Sir, I will take here R tending to 0. So electric field is tending to infinity. Because of which charge? Because of Q. See, when R is 0, this is giving infinite electric field. This charge don't even matter because this is giving infinite. This will give finite, overall infinite. and positive charge give field away. Positive charge give field away. Away means right. So plus infinity. Is it? Right field is what? We have taken what convention? Right means plus infinity. It starts from here. Come here. R is tending to 0. Electric field will tend to R is, let me draw here. R is tending to 0. Electric field will tend to infinity. Negative charge. So at this point, electric field because of negative charge will be towards. Towards means right. Again plus infinity. This is also plus infinity. So from here to here, and it's obvious, you take any point in between, positive will give away, negative will give towards, both the field are in same direction, field can never become 0. The point, if the field is becoming 0, it will cut the axis. Field is on the y-axis. If it's 0, it will cut the x-axis because y is 0 on the x-axis. It will never cut in this case. So it will go from here to here. If you have drawn like this, it's wrong. We cannot draw symmetric. Don't draw symmetric. Charge are not equal. This is minus 4q. Most of the region, this will dominate. So graph will be like this. The minimum value will come close to what? Q. This will dominate most of the region. Dominate most of the region. Clear? Come here. R is tending to 0. Electric field is tending to infinity. Negative charge, field will be towards. Negative means on this point field will be towards. Towards means left. Left means minus infinity here. And when distance is infinity, electric field because of both will be 0. So graph will be like this. Clear? Now come to this part. This part is very, very important. You know why? At this point R is tending to 0. Electric field is tending to infinity. Positive charge means electric field will be away. Away means left. Left means minus. Electric field left means minus. So minus infinity. Electric field start from minus infinity. But here electric field has to become 0 also. Whatever cases we have done till now, here field was becoming only 0 at infinity. But here field has to become 0 here. In the previous cases, the field has become 0 in between. So the point where field has become 0, the graph has cut the axis. The graph has cut the axis. So same here also, the point where field is becoming 0, at this point graph has to cut this axis. So graph will start from here and cut here because here field is 0. And again at infinity again field will become 0. When distance will go to infinity, electric field will tend to what? 0. So again finally 0. So start from here, go here, then finally 0. This will be the graph. Are you understanding? Starting from here, here, connect the dots. It will go from here to here, then from here to here, 0 to again 0. It means 0 to maximum, again maximum to 0. This will be the diagram. Clear? Equations and all, I don't think they will ask. If they ask, you can just take a random point. If you want, you can find electric field as a function of distance. That is not a problem. Okay, you can take any point, find field because of this, find field because of this. Okay, and you can just find the equation in terms of variable, whatever you are taking. Understood? Now this can come in JEE Advanced. This is a very good problem. I hope you all understood. Clear? You can pause and write. You can pause and write. So in the previous problems, it was fine. The field was not becoming 0 here. It was becoming 0 in between. But in this case, we know when the charges are opposite, 1q, 1 minus 4q, the field becomes 0 outside, closer to a smaller charge. So here somewhere field will become 0. So it means, you know, before this point, Q is dominating. Who is showing domination? Q. And after this point, minus 4Q is showing domination. This is what is happening. Here always minus 4Q is showing domination. This is the minimum point. Before this, Q is dominating. After this, minus 4Q is dominating. And here, before this, you can see this Q is dominating. Is it? See here the field is infinity because of Q, minus infinity. Then 0. And after this, minus 4Q is dominating. I hope you understood. Clear? All of you practice all the questions whatever I have given. It will, if you find any difficulty, just let me know. One more thing, if suppose this question comes in JEE Mains or Advanced, one way is there to eliminate some of the options. The way is, you can see electric field graph, these two are always diagonally opposite. See, if graph is here, it will be here. Here, it will be here. Is it? Same here. So opposite graph will be here. You will not see graph here and here. No, never. See here and here. Opposite, diagonally opposite. Check all the graph. Here and here, diagonally opposite. 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 The reason is, if you take a positive charge Q, on the right, if it's giving field left or right charge, on the right side, if it's giving field in this direction, on the left side, it will give field in this direction. So if you take a charge, on one side, if the field is right, other side the field is left. So that's why one side the graph is coming from the top, so other side from the bottom. Or if this side from the top, so this side from the bottom. In this way, you can eliminate some of the options. Clear? So this is for today's lecture. I am not taking that Coulomb's, not Coulomb's, that vector form question. I will take in the next video. In the next video, we will take some continuous charge distribution and we will find electric field because of those distributions. Okay. So just keep on studying. Just revise the notes properly. If you are seeing this lecture, I will prefer go and just have a look on Coulomb's law, all the parts, then come here, it will be good for you. Because most of the things I have done there only. And you know, same graph they can ask. They will say that a charge is going from here to here. How much force the charge will feel. So whatever graph I will get for electric field, same graph I will get for a charge Q naught, for the force on a charge Q naught. Is it? If I take a charge Q naught from here to here, what force the charge will experience? F is equal to charge into electric field at that point. So whatever be the electric field graph, that will be the force graph. Is it clear? Okay. So keep on studying. Okay. All the best. Bye.